This PowerPoint, Are You Ready?, is meant to be a reminder of some of the chemistry terms that you've learned through your high school career. A lot of these terms will come up when we're talking about various biochemical processes in our biology this year. So we'll go all the way back to grade 9 to start with. You should be very familiar, very comfortable with the atomic structure, basic atomic structure, and the subatomic particles and the charges and masses of those particles, where they're located, and so on. So throw your mind back to grade 9. You should have no trouble remembering. The periodic table was something we used in grade 9. And then a lot more in grade 10. So I think there was even a grade 9 exam question about this kind of stuff. 8 things you can remember from the periodic table in your grade 9. We use this a lot more effectively, really, in grade 10 when we started looking at ionic and covalent bonding, and we were looking for valence shells and how many electrons were in those shells and so on. So you became a bit more familiar with how useful the periodic table can be in grade 10. Something that we didn't touch on very much, except for possibly a definition, in grade 9 and 10 is the concept of isotopes. I think you did a little more work on that if you've taken grade 11 chemistry, where I think you do the calculation for figuring out atomic mass and how the various isotopes of a particular element contribute to that mass. We won't be doing anything like that this year. We may, it may come up, the idea of isotopes may come up, and a couple of places that you may have heard of isotopes in sort of an application role might be in your grade 11 biology. You did a unit on evolution, and you may have read or heard a little bit about the idea of carbon dating and how we can use the radioactive decay of carbon to help us figure out how old some things are. And we can do that. It works pretty well for things that aren't too old. Another application of isotopes that you may be familiar with is for medical imaging, and we did talk a bit about medical imaging in grade 10. So the thing that is fairly common, or one application that's fairly common with this, is the scan where if you've got some maybe digestive issues, a suspected ulcer or something like that. For those of you going to university, maybe that'll be something that happens in the future. And you head over to the doctor, and he sends you to get a barium scan or barium X-ray. And when you get to the place where you're doing that scan, you're in the room and ready to go, they'll get you to drink a barium shake. And it's sort of a chalky, yucky shake that you drink, and they can track the radioactive portion of the barium as you drink it, so they can tell how you're swallowing, and they can see if there's any lesions or any fissures in your digestive tract. So that might be another place where you've heard of isotopes. Ions we talked a lot about in grade 10, and I'm sure you guys are pretty comfortable at this point with ionic compounds. So the idea of donating or receiving electrons. And we also are pretty familiar with how to use the periodic table to figure out how that bonding will occur. In grade 10, we also did a lot of work on compounds. So in grade 10, as I was saying, the compound formation was something that we looked at quite closely in our chemistry unit, where we were looking at either covalent or ionic bonding. On this slide, we see a comparison of the two, and that should be pretty familiar to you. Now this point about electronegativity, if you've taken grade 11 chemistry, is something that you spent some time working on. If you stopped and didn't take chemistry after grade 10, electronegativity will be a new term for you. Electronegativity is the idea, or is a number assigned to the idea that certain atoms, certain elements are going to have a greater hold on electrons than others. So it's a comparable or a compared scale between the elements that are on the periodic table. So if there is an electronegativity difference between the electronegativity numbers of two atoms, and that difference is greater than or equal to 1.7, we have the potential there for an ionic bond to form. And if you learned a slightly different number there, don't worry about it. A lot of texts will use 1.65 or round it up to 1.65, or they'll round it up to 1.7. Sorry. And we can also see in the covalent bond side that the electronegativity difference there is less than 1.7. So their electronegativity numbers would be a little bit closer together for a covalent bond. There's a couple of examples for you. So electronegativity is a periodic trend, and again, you're familiar with that if you took grade 11 chemistry. You can see from the graphic here that the trend moves from low electronegativity in the bottom left-hand side of the periodic table up to the highest electronegativity in the halogens. So the top of the halogens would be where you would find the elements with the highest electronegativity or greatest electronegativity. So as I mentioned in the last slide, it as a definition is the element's ability to attract electrons. As an example here, we've got bromine that has an electronegativity number of 2.8, and chlorine that has an electronegativity number of 3.0. And clearly chlorine has the greater hold on the electrons, though not a lot different from the hold that bromine has. Because of that, when we look at the difference between these two, we can see that the difference is only 0.2, so they would form a covalent bond. If you look at this little partial equation down here, this is not, the formulas are not correct here, and it's not a balanced equation, but if we added bromine to chlorine, we would find that chlorine, because it has a slightly larger electronegativity number, would have a bigger pull on the electrons, and the electrons would spend a little bit more time around chlorine than they did around bromine. Of course, you guys know that this is not a correct formula or balanced equation, because bromine and chlorine are both diatomic molecules. So again, bromine in this case would be slightly positive and sort of set up a positive end to this molecule, and chlorine would be slightly negative and would set up sort of a negative end on this molecule.